Hi, everybody. Today we're on Unit 9, Lesson 4, and we're going to be talking about double angle identities. So in this lesson, we're first going to derive the identities for sine 2 theta, cosine 2 theta, and tangent 2 theta by using the sum identities that we learned in our previous lessons. Now, this is the first time I'm actually deriving formulas for you because I honestly think it helps to see where some of our formulas come from. So we can say that the sine of 2 theta is the sine of theta plus theta. And I hope that makes sense to people. If we just add two of the same angle together, we get two of them. And if we recall from our previous lesson, the sine of A plus B, now you don't have to memorize these. Okay, we just have to know how to use them. Sine A cosine B plus cos A sine B. So what we're going to do is we're going to substitute into our sine formula. Sine theta cosine theta plus cosine theta times sine theta. And if you recall in multiplication, so sine theta and cosine theta, they're actually the same thing. Order does not matter, so we could rewrite these. And now we're adding two of the same things together, so we can say that the sine of 2 theta equals 2 sine theta cosine theta. And now this is just one other identity. So if we ever see sine of 2 theta in something, we can replace it with 2 sine theta cosine theta. We can also evaluate different things with it. So we're going to talk about both of those things later on in the lesson. Now let's do the same for the cosine. So cosine 2 theta is equal to, and if we recall our cosine formula, this one is cos A, cos B, minus sine A, sine B. And we're just going to rewrite cosine again as theta plus theta, and then substitute it into our formula. And cosine times cosine gives us cosine squared theta. Sine times sine gives us sine squared theta. And notice here, it's almost just like the Pythagorean identity, except now there's a minus in between. So we really have to be careful. And because of the relationship to the Pythagorean identity, we can rewrite this. Okay, so this is one version, but we could also rewrite this by replacing cosine squared theta with 1 minus sine squared theta. And then we get an alternate version, 1 minus 2 sine squared theta. And this is something we can also use. So we have one version here, an alternate but equivalent version here. And there's going to be one more thing we can do. Cosine 2 theta, if we start at the beginning again here, at the original formula we got, this time if I rewrite the sine squared as 1 minus cosine squared theta and distribute and simplify, two cosine squared theta minus 1. So the double angle formula for the cosine has 3 versions that can be used. So we have to, kind of think about things sometimes when we're going through these problems. And the last formula that we're going to derive today is the double angle identity for the tangent function. Similar to the problems we did above, we're going to rewrite 2 theta as theta plus theta. And I have my tangent identity here. And once again, all I'm going to do is substitute into my sum formula. Tan theta times tan theta over 1 minus tan theta times tan theta. And I copied this down wrong. This has a plus in between. I knew I did something wrong. I'm going to give you guys a second to correct this. Okay, so there should be a plus in between there. I'm very sorry. And cleaning this guy up, tan theta plus tan theta gives me 2 tan theta over 1 minus tangent squared theta. Okay, so here we have just a few more identities we can use. The sine of the double angle, cosine of the double angle, and tangent of the double angle. We're just going to practice a few different types of problems, very similar to what we've already done. So let's say we have the sine of theta equals -3/5, and the tangent of theta is positive. Okay, so this is our given information. Answer the following questions. In which quadrant does theta terminate, and explain your reasoning? So if we're thinking about what quadrant this angle lies in, all students take calculus. If the sine is negative and the tangent is positive, so my sine is negative in 3 and 4, and the tangent is positive in 1 and 4, well, we're going to be in quadrant 3. Okay. Now draw the angle and label the reference triangle. So for anyone that didn't understand some of the work we did the other day, this will be helpful. So we're going to draw our angle in quadrant 3. There's my reference angle. And if I go back up to the sine, -3/5, opposite over hypotenuse. So opposite, I label with the appropriate sign according to where I am in the XY axis, hypotenuse. And we should recognize this as one of our 3, 4, 5 triangles. And again, I'm labeling because I'm in the negative part of the y-axis. So I'm always labeling my legs positive or negative according to where they are. And the hypotenuse is always positive. And in the next part of the problem, we want to order the sine of 2 theta, cosine of 2 theta, and tangent of 2 theta from least to greatest. So which means I have to find the value of each of these. Sine of 2 theta equals 2 sine theta, cosine theta. Two, the sine of theta, that was given to me, so I'm just gonna, that's -3/5. And the cosine of theta, I can work right off my triangle. And that's gonna be adjacent over hypotenuse. And I'm just gonna multiply this fraction together. Put that over a 1. We're gonna multiply across the top, across the bottom. 2 times -3, so I get positive 24 over 25. So that's my answer. Now I want to find the value of cosine of 2 theta. So here I could literally choose from either one of these formulas. Now I'm going to go with this one because they gave me the sign in the original problem, And that way, in case I made a mistake finding my cosine, it won't affect me. One minus two. I'm going to set up my sine function and square it. Just work out the math now. 1 minus 2 times -3 squared. So I have 9 over 25, which is 1 minus 18 over 25. And my overall answer, 25 minus 18, is 7 over 25. So far I got my sine, my cosine, and the last is my tangent. And I'm substituting into the formula that I derived above. 2 tan theta over 1 minus tangent squared theta. 2 times the tangent of theta, opposite over adjacent, so it's going to be a positive value, over 1 minus the tangent squared of theta is going to be 3/4 squared. And again, it's just a little math, and I want you practicing by hand. So this is 2 over 1. So in the numerator, oh, I could simplify it, make my life easy. In the numerator, I have 3/2 over 1 minus 9 over 16, right? So that's going to be 7 over 16. Flip this guy up, 16 over 7. And here you could do whatever you want, 48 over 14, and simplify it from there. I'd probably do that, and I wind up getting 24 over 7. So if I'm ordering these from least to greatest, my lowest number, my lowest value is cosine of 2 theta, which is less than the next guy, right, was sine of 2 theta. And 24 over 7 is my biggest guy, tan of 2 theta. And again, I don't know if I'd ever do that to you, make you order them, but just showing you different things that we could ask you. Lastly, let's verify that the equation cotan theta minus tan theta equals 2 cotan 2 theta is a trig identity. So now, like we did with the previous examples, we can incorporate our new formula into different types of identities. So when we're verifying, remember, we're going to rewrite everything, making substitutions. So cotan theta is cosine over sine. Oh, I'm going to skip to C's and S's in just a second. Minus sine over cosine equals 2 cotan 2 theta. So cotan 2 theta is going to be cosine 2 theta over sine of 2 theta. And now I'm just going to replace. Can't do anything over here. I can combine like terms over here though. Cosine, cosine, sine, sine. So I would have cosine squared minus sine squared over sine times cosine. And on the other side of my equal sign, I get 2. And I'm not sure which one to use. It's not going to matter. I'm going to use the substitution cosine squared theta minus sine squared theta. And if it's a bad call, then it's fine. Well, the math will work out no matter what identity you use. Now, cosine squared theta minus sine squared theta is cosine of 2 theta And over here, oh, I'm kind of stupid. Oh, that's okay. Cosine squared theta minus sine squared theta over sine theta cosine theta. And now here it doesn't matter. We could go backwards and rewrite this, or we could rewrite this as cosine 2 theta. I think I'll write the other side. And I would just want to point out really quickly, okay, I can't cancel anything because this is a single theta and this is a double angle. So be really careful of that when you're working through these types of examples, okay? When it's sine squared over sine, you can do it. But when you have a multiple angle inside, you can't cancel things out. So we made it check, so we're done, okay? I did work out the rest of the examples on the page for you, and you could hopefully try to work on them on your own. Okay. Watching them, watching your math very carefully. This last example here, okay, this is a very difficult problem. So if you want to try to make sense of it, you could surely take a few minutes right now and work through the math. But that one is a pretty intense problem. And I would never go that crazy. Okay, it's good math to see, but it's not something I would expect you to do on an assessment. Okay. Maybe on a group work where you have friends to talk to, but not on an assessment. Um, so this is the last lesson for this part of our unit, and hopefully we'll see you soon. Thank you.